4.2, factoring simple trinomials. Now, you should be scared that it says simple there. I mean, not scared for today. Today should be like, okay, this is going to be simple trinomials, but is there something not simple coming? And the answer is a big yes. One of the big problems in grade 10 is coming up this week, but it's not today. Today, I think most people like this type of factoring, okay? So put all that stress on the shelf and focus on factoring simple trinomials. Now, what's a trinomial? Well, we got to get to the bottom of that first so we can recognize. So we want to factor a trinomial of the form ax squared plus bx plus c, where a equals 1. So a trinomial that we'll be looking at will be an x squared term, an x term, and a constant term. But the x squared term only has coefficient 1. That's all that's going to happen today. To warm up for that, we're going to review multiplying binomials. And I tried to foreshadow what was happening in a previous lesson, but I'll try and do a better job today. By the time I finish multiplying these out, I hope you realize these examples aren't here to review FOIL. It can work like that. If you need to review FOIL, yeah, it'll do that. But that's not why I'm doing them. I'm up to something more, okay? So, do we remember how to handle this? Everybody says FOIL, but I don't know if people think FOIL. Maybe they do. I think they think arrows. They go, okay, x times x, which is x squared. That's the first two terms being multiplied together. That's where FOIL comes from. F for first. Then you multiply this x times the 3. That's the outside terms. See FOIL? F-O-I-L. But again, I think most people do the arrows. But again, you can use FOIL to think it out. Then the inside terms, 2 and x. Then the last terms, plus 6. So let me write this up just in case. Up here, FOIL. First, outside, inside, last. Now let me tell you why I don't love the word FOIL. It's good. It's a good grade 10 word. In future grades, it won't be 2 terms and 2 terms. It might be 2 terms and 3 terms, or 1 term and 5 terms. And then FOIL doesn't really help. The arrows are better then. The arrow's just like, oh, just multiply this thing out, okay? But I like FOIL, but arrows. Is this good? Because we're trying to move on from this. We're trying to do something different today. We're just trying to maybe review this a little bit. There is one more thing to do, though. What's the other thing to do? Simplify. Collect those 2 like terms. Now, here's where the lesson really starts. If you really want to understand what this lesson's about, listen to what I say here, which wasn't a big deal in other lessons, but it's a big deal today. Oh, okay. So x squared, I'm putting 3x and 2x together, so I'm adding the 3 and the 2 to get 5x. And then there's the 6. That's me foreshadowing. That's me going, did you notice what happened there? Maybe you don't notice yet. Well, that's okay. We get to go again. But let's not wait around till tonight. Here, you try this one with just positives again. You try multiplying it out and make sure you've got this down pat.
That's 2x plus 15x, right?
What's that?
That's x squared plus 5x, right?
X squared plus 5x. Yes, good. A little neater there. Yes? Yeah. X squared plus 5x plus 6. You try the next one. Then we'll take it up and just make sure. We got to make sure we have FOIL down pat, like cold, before we can move on. But you can check your answers with mine. I'm going to do it here. Sort of quietly, giving you your chance. How'd that step go? Is it okay? Lots of nods and thumbs up there. It's good. And then what's the next step? Add those 2 middle terms together. Dun, dun, dun. Like if this was a movie, that would be the big moment of understanding and all this. That x term comes from adding the 5 and the 4. The x term comes from adding the 5 and the 4. Dun, dun, dun. Yeah. We'll do one more. and talk about the constant term, okay? All the foreshadowing, almost done here. Maybe you're like, I totally get, I got it. Yeah, I'm giving it all away. Watch this one. Multiply the first two terms. Oh, multiplying the first two terms gives the first term, x squared. And then I have these two, 1x and 7x, which are going to add to give the x term. And then, listening ears on, here's the other part of my foreshadowing. That last term, 7 times 1, that's where it comes from, 7 times 1. I'm not making up a shortcut for FOIL. I don't think you should shortcut FOIL. I'm just trying to understand where all these numbers are coming from. What do you notice about the b and c values? Okay, let's talk about the b. That was the b every time. That was that middle term. Where did it come from every single time? He said, hoping he already gave it away. What's that? Where did the b come from each time? How did it come from numbers? When there's 3 and 2, I got 5. When there's 4 and 5, there was 9. When I got 7 and 1, I got 8. She said add the zeros. It's very close. It's add the numbers because the zeros would be the opposite sign, wouldn't they? But yeah, you're right. The b is the numbers added. The c, what do you see? About the c. The c is the numbers multiplied. Maybe I gave that away in another lesson. But to be clear, I'm not trying to make a shortcut of FOIL. Don't try to shortcut FOIL. That's a method or a path to making mistakes. I'm up to something else here. B is the numbers added. C is the numbers multiplied. Okay. Okay, that's good. Those are good sentences. Those are so good. I mean, not just so good for this year, all through high school. Those get the yellow highlight like, hey, that's good stuff. It's important. Important. Difficult? Well, I don't know. It depends on how well you and I have done. If I've explained it well and you've listened well, you might be like, yeah, okay, that's pretty straightforward, I guess. Yeah. Questions? All right, here we go. Now, to factor a trinomial, such as x squared plus 5x plus 6, is to write it as two binomials. See, we've been going this way. We've been going x plus 2x plus 3 to x squared plus 5x plus 6. But to get context, we found out that when we write it this way, it's hard to get too much information out of that thing. It doesn't present a lot of information. But if it's factored, we can get the zeros, and if we got the zeros, we can get the axis of symmetry, and if we got the axis of symmetry, we can get the vertex. Like, factored forms are way better. Here, add to your note here. Draw your best smiley face. Here's my best smiley face. Maybe you're a better artist than me and you can draw something. We like factored form. That is truth. In fact, my grade 11s right now they are factoring crazy stuff. They're so happy once it's factored. Once it's factored, like, now life's easy. Now that I have it factored. We want to factor. So, in general now, this is hard. This is what I did in the previous page, but it's difficult. If you expand two binomials like this, you get x squared, you get an nx, and you get an mx. And don't let the n and m mess with your brain. Those are just the two numbers, whatever they are, 3 and 2, 5 and 7. And then you get an mn. So what you get is, the middle term is those two numbers added, and the last term is those two multiplied. Now, friends, if right there your brain broke into panic mode, you're like, I was with you until you wrote all the m's and n's, and now it just looks like someone threw up alphagettis on my page, do not panic. The idea that the middle term is the numbers added and the last term is the numbers multiplied, that's what we really need. This is just me getting ready for tougher algebra in later courses, just starting to go, hey, can we generalize these things in algebraic form like this? Oh, and here it is. Oh, well, not just yellow highlighter. Get out your best favorite highlighter. I'll use pink. Oh, that is good. That's rich highlighting. There. We can see in our answer the middle number is the result of adding the two original values, and the last number is the result of multiplying the two values. That's the stuff. If this was a really great school, I'd go, yes, you understand? You'd say yes, and then I'd send you all to buy lunch, pizza, pad thai, Chinese food, whatever your favorite thing was, sit under a tree like Isaac Newton and just think that over and go, wow, that's good. That's good enough for a lesson right there. But we will carry on and not just think about it, we will use it. Two-factor, here it comes. Wake up. This is the big moment. In order to factor this expression. Come on, pen, start working now. Oh, and hey, because I'm so excited, I'll switch to spring green. What a nice day it was yesterday. In order to factor this expression, we need to find the two numbers that multiply to 18 and add to 11. Here's what some people do. As soon as they get a trinomial like this, they write the multiply symbol over the 18 and the add symbol over the 11. Go, that's what I seek. That's what I'm looking for. Now, these will progress. So if the numbers popped into your head as soon as I wrote that, because you're so good at your multiplication tables, don't leave yet. Check out my method. Because right now the numbers are 11 and 18, and hopefully most of you are like, oh, that's pretty easy. But if the numbers are 132 and 23, you might need a plan, okay? So, old math teacher trick. The trick's old, not the math teacher. Yes? Old math teacher trick is to do an easy question in a systematic manner, even though you probably could do it with just your brain. And now I'm ready for any time the numbers get big. Yes? I don't have to try and explain the method with a tough question. Here's the plan. Systematically list everything that multiplies to 18. Start with 1. 1 multiplies with 18 to give 18. Then add them together and see if it's the right pair. What's 1 plus 18? Does that add to 11? No, that doesn't add to 11. 2 times 9. And again, if you're good at your multiplication tables, you're like, why are you wasting my time, Mr. Todd? I knew what the numbers were as soon as you wrote it down. I'm like, very good. Well done. You're so smart. I'm getting you ready in case these numbers get out of hand, which they will at some point. You've got to plan and go, okay, hold on. Big numbers. So I check 2. See, I'm going 1, 2. I'm systematically checking this out. 2 plus 9, does 2 plus 9 equal 11? It does. So when you first saw me build this table, you'd be like, I got to write them all out? No, I wouldn't write them all out. I'd add them as I go, and hopefully I eventually run into it. Now, if you're like, what if I just know them? What if I just look at it and go, then don't build the table. Yeah? You'll do this question, you're just like, oh, I already know what they are. X plus 2, X plus 9, I'm all done. Good. I'm so happy for you. Aren't you brilliant? Yes? Get one of your Easter chocolates out and eat it. I'm amazed at you. Yes? But do you understand my method is for when the numbers are too big for your brain, or you're a little tired, or you're on the test and you're like, oh, I don't want to make a mistake here. Better get this right. Does it work? What's nice about factoring, what lots of people love about factoring is it's checkable. You don't have to look in the back of the book. You just FOIL it. X times x is x times x, x squared. Then x times 9 and 2 times x, that's 11x. And 2 times 9 is 18. Good stuff. Good stuff. It is simple. Oh, good. There, somebody used the word. Today, life is actually pretty simple. I'm over-teaching it. Over-teaching it to get ready for what's coming. There's something coming, and we better be ready for it. Okay? Not today, though. Not today. What's the only thing we got to worry about today? Negatives. No! But we're going to keep our attitude good. We're going to be positive about negatives. Let's try another one with just positives, just to try the method. What do the two numbers I seek, what do you know about them? Don't tell me the numbers. Some of you are like, I already know the numbers. They're real numbers. But what evidence do I have to find them? What do they have to multiply to? 12. And what do they have to add to? 8. That's what a lot of people do. But right above it, they write add and multiply to remember those are the two things. Then you go over here and systematically start with 1. Is there shortcuts if the numbers are easy? Yes, please. Do it as fast as you can. But if the numbers are too big for you, you go over here and go, okay, what multiplies to 12? 1 and 12. Does that add to 8? No, that doesn't add to 8. Then what? 2 and 6. Does that add to 8? Yes. Oh, I only have to do it twice every time? I know the first two examples you only had to do 2, but it may be more. But it depends on this last number. A 12, there's only one more set to check. The other set you check would be 3 and 4, and that doesn't work, right? So it depends on that last number. If the last number is 24, things get pretty interesting. If the last number is 88, things get really interesting, right? Anyways, I already found them. X plus 2, x plus 6, and you'd have to be silly not to quickly check that with FOIL in your head. X times x is x squared. X times 6 and 2 times x, there's the 8x, and 2 times 6 is 12. Pretty easy, without even writing it down, to double check that this thing works. You're like, why didn't you show us this last week? Would have been nice to be able to just factor these things. Yep, we're going to go all through it again, now with our new factoring ability. But do you have questions? What do we got to worry about? Negatives. Negatives are the only possibility of messing you up here. Okay? Here we go. X squared minus 10x plus 9. Let's go through the systematic method. What do they have to multiply to? 9. What do they have to add to? Negative 10. Now be careful. I say be careful with what you're writing down that multiplies to 9. I say over here 1 and 9 multiplies to give 9. And what's 1 plus 9? 10. Oh, we want negative 10. So this is where getting used to positive negatives. There is some help there. When you get the wrong sign, negative 1, negative 9. Okay? So that's one way this can work out is you go, oh, I'll just do the positives. And when I get the wrong answer, the exact wrong answer, I know I found it, but I've got to go with negatives. Hopefully you're like, well, okay, that's not so bad. Is that as bad as it can get? And the answer is no. The other thing that can come up is that last number multiplies to a negative. Then you have to be careful. You've got to write down things that multiply to negative 15, not to positive 15. So if I was going to do this systematically, I wouldn't write 1 and 15. That doesn't multiply to negative 15. 1 and negative 15. So really make sure what you've got over there multiplies to to the C value. Now, is 1 minus 15 negative 14? I got lucky here. I built it that way on purpose just to go, what's the worst that could happen here now? Is that I'd have to keep going through until I found it. But I was just trying to do 2 that basically show off what we're up against. Because when I said negatives, a couple people were like, oh, no. Yeah, negatives are trouble. They are. But I don't know that they're a big problem to manage here if you just are careful with what you write down over here and make sure it does multiply to what was given. Yes? But do you have any questions? Well, here's the question you should be asking. So it's just like trial and error? Just play around until I get the right two numbers? The answer, yes. Yes, that is true. It's basically just trial and error. But it's systematic trial and error. It's like, I'm going to go through every possible set until I knock this down and find the right set. I'm counting that as my stretching for the day. There, you can tell Mrs. Todd did all my stretching. Okay. Do you need more time on that one? Nuh-uh. You try. Okay. Let's not wait till tonight that you weren't listening. Try A, B, C, and D, but don't try example 4. That's for me. Okay? You try these 4. And then, if anybody wants to come up and share, but if you come to share everything you wrote down. If that's not much, that's fine. What do I give? Video people, 4 questions, 4 minutes, 4-minute timer. See what you can do in 4 minutes. And then we'll see if there's brave people to share on a Monday. Mr. Todd, stop talking so we can do this. Okay, sorry. Excuse me. You're a very chatty class, and I like that about you. I'm not trying to be critical. It actually is able to make me tell when you need more time. When it's still quiet, I know you're still working, because you immediately start chatting. It sounds like I'm getting down on you for chatting. I'm not at all. That's not what I mean at all. What I mean is it's easy to tell when you're working, because you're so quiet. It's like when the hamburgers first come out, right? It gets real quiet in your house for a few minutes, as everybody's like, stop talking, Mr. Tots, so we can do our work. I still got 2 minutes on the clock. First time through, 4 of these in 4 minutes, pretty good. This homework can go really fast if you're good at your multiplication tables. Stop talking, Mr. Todd. Okay, sorry. Oh. Oh, it's okay. Thought I messed up. Oh. Yeah, that's right. "40 seconds. If you're not done in 40 seconds, you're fired." No, that's not true. And if you're not done in 40 seconds, it's not like something's wrong with you or that you should have been done. No, I don't mean like that at all. I don't mean that. I mean, in 40 seconds, let's see how you did. That's what I mean, yeah. Turned that into a gong show, didn't I? Okay, my timer's gone off. Actually, you still get more time because if I can convince someone to share, you got, while they're putting it up there, to keep working on other ones. Where's my pen? Austin, you gonna share the first one?
Yeah.
If you can, don't just write down the answer, unless it was too easy. If you can write down something else to help people, that's good. Now, the only thing with that pen is it's got to be straight up and down. It doesn't like to be on an angle like that, okay?
Yes, sir. Hi. So we've got 9 and 18. So we're gonna write our things.
Oh, hold on. Something's just happened. It's not your fault. Yeah. Oh, yeah. Yeah, good.
Boom. So we're at 9.
Yeah. Just get used to pressing just a little harder. Yes. Yeah.
And we got times.
Yeah.
18.
Let me see. I don't know what's happening here.
And then we also got a goofy whiteboard. And, yep.
Just press down, straight down a little harder. Oh, not that hard. Okay, no, it's not. See, now you guys aren't laughing so hard when I have trouble up here with this thing, right? Maybe it's lighter. Let's see. Yeah, just nice and smooth.
Okay.
Did I give it away? 1?
So we got 1 and 9 for the first one. And that does not add to either of them. So it doesn't add to 9, and it doesn't times to 18. So we're going to move on
Yeah.
to 2 times 8.
No, 2 times 9.
2 times 9.
Yeah.
Yeah.
That multiplies
So
to
that
18.
gets 18.
Yeah, good.
But 2 plus 9 is not 9.
No, that's right.
So what do we do?
I like this.
Now-
I'm trying to get it on a video here.
Move on to 3.
Yeah.
And then what adds to 18?
No, multiplies to 18.
Same thing.
Yeah. 6. Good.
And multiplies to 18, adds to 9.
That's the ones. Good.
Next.
Now what do you write?
Crazy. So we got our 3. And then we got to add it
Yeah.
to x.
Yes.
We're going to do a little brackets.
Yeah.
Because it's important. And then there are 6. So there's 6 plus x.
Good.
Kaboom.
Yeah. It's right. Now, did some of you write it with the x first? That's how you often see it. And moving forward, we might like the x at the front. But can you see how it's the same? Yep. All right. Who's next? Josh. He did good explaining. If your explaining is different, or if you got something different to share, that's fine. We don't have to, but at least share. At least, you don't have to speak, but you have to at least show what you were thinking.
I'll put like the plus, and then like the, oh, that's the wrong one, but it'll work.
Yeah, all right. We got the gist of it.
You just gotta like, I don't know, just put like a little chart.
Oh, he made a chart.
So that you know that you gotta like, times it gotta equal to 20,
Yeah.
and you gotta add 2 in brackets, negative 9.
Good. I like this.
And so then obviously we have the 2. You start, I mean, obviously, no, I'm not that dumb. 2 and 10. No.
Yeah.
Then you get to like 4 and 5, because you can't do 3, because if you decimals.
Yeah.
Gives you like positive 9, but you want negative.
Yes.
So that means obviously you have to flip the sign, so that's how you know.
Good.
It becomes that. So instead of going x plus, nope, it'd be x minus 4.
Yeah.
Of course in brackets. And then x minus 5. And then you can be so happy. It's all done. Oh my god, it's all done.
All right. Thank you. Beautiful work. My turn to jump in. I'm not going to say anything about what they said. They covered it really good. Do you know on your test, that little communication thing, it's like, oh, you showed great form? I haven't said much about it, really. And I've just been giving everybody full marks. This time when I marked your test, I got my highlighter out in yellow, and I highlighted things that I might have taken off form points for. So when you get your test back, look for those highlighters. One of the things I highlighted and didn't take marks off for, I didn't take marks off this time, so it's my warning to you. Next time, if you don't do these things, and it's putting an equal sign out here. That's one of the things I talked about, making sure there's an equal sign that go. This equals this. So if you're not doing that, add that to your move. Austin.
When do you think we'll get the test back?
I could give them back today. Oh, really? Yeah. Depending how we do in time-wise. We should be good. I want to print out updated marks. I want to laugh at the people who didn't do their online quiz yet, and I put a 0 in because I think it's hilarious. Yeah, it's good. Who's up? Such an interesting class.
I have to leave the calculator.
Yeah. You're fired. Yeah. When I put zeros in there, it's just hilarious to me to watch your reaction when you get your updated mark and it's not done. But again, we want to move towards getting them done before the test because it's helpful to do the work before the test so that you're ready for the test. But okay, no panic. No panic. I'm grabbing your frown, turning it upside down. Yeah. Whoa, what happened? Me? See, it's not quite as well behaved as you think it is. You're always laughing at me. You gotta, yep, and just straight up and down. There you go, you're going good. Yeah. Yeah. Yeah.
-7.
4 and -7.
Actually, not 4, positive 4.
Yeah.
Right? Which equals to -3.
Yeah.
So both these equal to negative
Good.
3. We have x plus 4
Yeah.
equals this 4.
Yeah.
So we have x minus 7 because of this -7.
Yeah.
And there's the answer.
So the only thing I'll say is, when things get too jammed up like that, go ahead and write it down a little lower. No problem. Last one, who's up? Any sharing you can do is great. Doesn't have to be out loud explanations, but show us something. Yeah. Yeah. Oh, he's fancy. He's going to use the eraser. Good for you. Now back to the pen. And you can see which one you're on. Right there, it shows you. So you're back on pen now. You can see what you're doing.
I did 3 times 5, or a negative 3 times 5, which is negative 15. And then 5 minus 3 is also equals 2.
Yeah. It strikes me his multiplication tables are very like this for him, because he can jump right to it. It's like his brain does it so fast. So if that's the situation you're in and you did these 4 in like 5 seconds, no problem. But pay attention to the methods we're using, because when those numbers get out of hand, you're going to need a plan of action. Yes? Okay. Any questions there? Did he put the equal sign? He did. Easy to check too, right? All right, last two. Back to me. So if you've drifted off to sleep because you enjoy this working together, sharing time, everything, good. But you want to come back and check this out, because this will be the most important thing I say today. That part, I probably could have sent an email Sunday night and go, here, go to Khan Academy, watch a video on factoring simple trinomials, and I'll see you Tuesday. You probably didn't need me. You might need me for the next one.
What happened to your arm?
Well, you know, it's just another bar fight. You know how it is. Math teacher, sometimes you gotta. If you're out in public and you're doing a Rubik's Cube, someone says something, you gotta take care of business, right? Mr. Todd, you said at the start of this lesson that A value would be 1. And when you see that, you're like, this whole method is going to fall apart if that's a 3 out there. I agree. So then you raise your hand and go, what the heck is this question doing in today's stuff? We know how to do this, actually. This is the problem with factoring. The problem with factoring isn't the individual skills, it's which one to use. Let's rewind before the lesson started. You could have started to factor this thing.
You gotta find the one that you gotta factor that with the x's. So you do another table. It's 2 and 1 with like the 2 x's.
Oh yeah, you might be saying he might be a step ahead of us. He might be onto the ones on future days. I'm talking about last week's lesson on factoring. What's the first type of factoring to look for? What's it called?
Wait, could you not just do this?
Common factor. All right. So here's what I'm going to do for you. Watch this. Those of you who are watching the video, I'm going to the back of the classroom. No, front of the classroom, right here for you. The grade 11s, I put it back there. I'll put it right here. Put a little please leave on up there. That's what that means. Lets the other teachers, custodians know, don't erase this. Here. Common factor first. And if you have me as a teacher again next year, or the year after, for 2 semesters, that'll be up on the board. That skill is not going to go away. When factoring, the very first move is, hold on, before I even start, let me just see if there's a number that divides into all this. Is there a number that divides into all these?
So, wait. We're going to go back a bit. This lesson has like OK factors.
Yes.
So this lesson is satisfactory.
Satisfactory. I've been here 23 years. Somehow I didn't see that joke coming. It's a satisfactory lesson. Back to my question, though. Is there a number that divides into 3, into 36, and into 60? 3. Common factor first. The biggest reason why is it's just going to make all the numbers smaller. Won't that be easier to work with? If we did have to do crazy factoring, which we will by the time the chapter's out, let's at least do it with the smallest numbers we can. So if I take 3 out of all that, and again, I taught it 2 different ways, but I would encourage you to move towards going, okay, if I'm taking 3 out, then divide all those terms by 3. And I get x squared plus 12x plus 20. Now I have a trinomial, 3 terms, with an a value 1. Now you can do your multiplying and add. What multiplies to 20 but adds to 12? 10 and 2. Again, I'm doing this one faster without the systematic method because I'm giving permission to the people that can do these very quickly in your head. And don't feel bad if you can't. Like if it's like, no, these take me a little longer. I just need my calculator. No problem. Although you could improve. Get a little app on your phone. Get your multiplication tables back up to speed. It would really help here. The homework will go a lot faster. It's worth the investment to brush up on your multiplication tables a little bit. One more thing to show you. And this is really important. If there's a negative to bring out, your life will be 1,000 times easier if you common factor at least the negative out. So whatever that leading number is, take the negative out. Get the negatives out of this if you can. So even though 2 divides into all these, take negative 2 out. That's why this example is here, is to go, listen, if there's a negative on the front term, get it off of there. It's going to make your life a lot easier. And then I get x squared minus 10x plus 9 when I divide all of those by negative 2. I did that quickly because that really was last week's homework, which I should go check, shouldn't I? Now, 2 things that multiply to 9 but add to negative 10. Let's check. Negative 1, negative 9. Negative 3, negative 3. Oh, those are the only 2 pairs that multiply to 9? Which one adds to negative 10? Negative 1 and negative 9. I'm literally on one knee here, folks. On my bad knee, my knee looks worse than my arm.
Did you win?
Of course. Head faked him with a 4x4 cube. Uppercut, straight right, flurry to the solar plex, was over. Please, no matter how smart you think you are, do this homework. There is trouble looming. Winter is coming this week. We have to be rock stars at this to be ready for what's coming. Winter's coming. Oh, that's from Game of Thrones, right? Winter is coming. Khaleesi is coming to Westeros. Eh? Bad things are about to happen this week. We got to be ready. Please do your homework. So bad, I'm telling you, I'm checking homework tomorrow. It's the very first thing. When you walk in, I'll have this look on my face. Show me. Show me. Please? Please? I did my homework. Marked your test. Yes?
Thank you. We love and appreciate you.